Welcome to Unit 3.1. This is the content page Energy from the Sun lecture video. We will eventually learn about climate change and how humans and other organisms impact the environment. But first, we have to learn about where weather and climate comes from on our planet. So, the primary source of energy for the planet is the sun. It provides all of the energy that's needed for life to happen, for weather, ocean currents, seasons, and the climate. It all depends on the sun. Now, the inside of the Earth does have energy, does have thermal heat energy since it's molten, but since we're cut off from that source of energy by the lithosphere, that thick, hard, crusty part, really only organisms like tiny organisms that live near the hydrothermal vents deep in the ocean, they can use the energy of the Earth, the inside Earth, as an energy source. But for everything on the surface, the primary energy source is the sun. The sun is radiating solar radiation, solar energy from the sun, all out in all directions in space, and some of that hits the Earth. However, some of that solar radiation, some of that energy, although it does hit the Earth, depending on what surface it hits, it can either be absorbed or reflected back out. Things that are kind of shiny or light colored, white, like clouds or glaciers or even bodies of water, they can reflect the sun's energy back out into space. And things that are darker colored and certain gases in the atmosphere, those things can absorb that solar radiation, that sun's energy. So there's a nice balance. The weather that we get is due to how much solar radiation is actually absorbed on the Earth. The reflected stuff does not give us any energy. It's bounced back into space. So now, it's not just that simple, because obviously we have seasons. Especially in New Jersey, living in the northern hemisphere, we have different seasons at different times of the year. And so let's talk about why that happens. When you think about the Earth, you may think about the Earth like this picture, where the North Pole is pointing straight up, South Pole straight down, and it spins around that axis. Now, we do spin around that axis, however, it's not perfectly straight up and down. The Earth has a tilt. We call this obliquity. The axis of the Earth, the North and South Pole line that we spin around, we spin in this direction, is tilted 23.4 degrees, 23.5 to make it easy for you. That's called our obliquity. Since we're tilted a little bit, the equator ends up not being perfectly horizontal, it's kind of on an angle. So what does this mean when it comes to getting energy from the sun? So, depending on what time of the year it is, I'm going to use the northern hemisphere as our example since that's where we live. Let's say we live here right where this red dot is. Since the Earth is tilted on its axis, there are certain times of the year where we are either turned towards the sun or turned away from the sun. So if we look over here at December, this is called the winter solstice. This is when we have the shortest day of the year, the longest night. That's because, I'll draw the equator here, as the sun is emitting solar radiation out in all directions, the solar radiation that's hitting the Earth, more of that solar radiation, since in December the northern hemisphere is tilted away from the sun, more of that sun energy is hitting the southern hemisphere. So it's actually summer for people in the southern hemisphere in December. Up in the northern hemisphere, we're getting hit with less solar radiation, less energy, and it's less direct energy. So when we spin around this axis, we have less access to that energy. We have shorter days and we receive less energy. Now, if we go 6 months into the year, into June, the solar radiation, I'll draw the equator. The equator will be somewhere like here. You'll notice that now we are tilted towards the Earth because of that 23.5 degree tilt. Since we're pointed towards, sorry, I said towards the Earth. Since we're pointed towards the sun at this time of year, June, like the summer solstice, the longest day of the year, shortest night, we are getting more sun energy since we're tilted towards it. This gives us hotter days. Now, it's actually true that in June, in the summer, we are technically further away from the sun than in December. In our orbit around the sun, we're further away in June, closer to December. So people say, why is it so cold in December? It's not about how close you are to the sun. It's all about that tilt. In the winter, we get less sun energy because we're tilted away. In the summer, we get more. Now, if you go somewhere in between those, like during the spring and the fall, since we are no longer tilted towards or away from the sun, if you happen to be in March around the 20th, like the spring equinox, the northern and southern hemispheres both get the same amount of sunlight, and day and night are equally as long. And then that happens again in September around the 20th for the fall equinox. The day and night are about the same amount of time. The June solstice, summer solstice, happens around the 20th. In December, they're around the 20th. It's different, a little bit different every year. Okay. So that tilt has big effects on the weather and the sun radiation that we get. Now let's talk about latitude and longitude really quickly. The equator obviously is dead center in the middle of the Earth between the North and South poles. It's an imaginary horizontal line. We use latitude and longitude to talk about locations on the Earth. Anything north of the equator is a positive degree. Anything south is negative. See, here's positive 30 on the latitude, negative 30. Now longitude, we have the prime meridian, the line, the imaginary line that cuts the Earth into left and right halves. Anything to the west of that line is a negative degree. Anything to the east is a positive degree. But there kind of is an issue here. We have a north and south pole. Since the Earth is spinning in this direction, the equator is always in the same spot. Now the prime meridian, people had to decide where they were going to consider 0 degrees in the prime meridian. Since the Earth spins, we have to pick one spot and say, all right, well, that's where the prime meridian is. And they decided that that was in Greenwich, England. So this image over here, anything that is to the west of this line, like us in North America, is negative. Anything to the east will be positive degrees. Okay? If you need to re-go over this or a little bit confusing, remember this is a video. You can pause and rewind. What's very important here is understanding the obliquity of the Earth, how many degrees it is tilted, and how that affects the amount of solar radiation that we get.